Hey guys, welcome back to the Basement Workshop. In this video I am going to introduce you to two new purchases. One of which will be the largest, heaviest, most expensive piece of equipment I've ever purchased. It just arrived this afternoon. I haven't opened up the box yet, and I'm a little nervous about doing so. It came all the way from California via UPS. I don't know what kind of condition it's going to be in. But the other piece is in great condition and it works. But before we get into it, I want to talk a little bit about test equipment. So I've been gearing up for these alignment videos, and I've been giving it some thought into how to present them, and of course rearranging the workshop and getting new equipment out. I've gotten some comments that I think I need to address about equipment. In particular, the type of equipment that I've been demonstrating, acquiring, recommending. Let me start out by saying I don't think I've ever purchased a new piece of equipment in my life, except maybe a multimeter from Radio Shack when I was a teenager. I buy used equipment. Mainly because I think it is amazing with the advent of eBay and going to Hamfests and swap meets and surplus auctions and whatnot, that you can get amazing, sophisticated equipment inexpensively. Things I could never afford when they were new. Things I could never afford when they came out 20, 30, 40 years ago. Yeah, I'm an adult now. I have a job. I could save up and I could buy some of this stuff new. But I also like to fix things. I like to find things. And I work on vintage electronics, so sometimes it's nice to have some features that aren't really available on modern equipment. Or a lot of modern equipment is maybe geared towards different things. So I work on a lot of tube equipment. New stuff is geared towards solid state, low voltage stuff, and much higher frequency stuff. Like modern signal generators, maybe go up to well into the gigahertz. I'm working in the megahertz or kilohertz. I don't need gigahertz. But also, in particular, some of the vintage stuff I have and have recommended isn't so much because it is the ideal instrument for the task at hand or the application. It's because it's readily available. For example, the Fluke 27 multimeter that I've recommended many times and many other YouTubers use. It's not because it's the greatest meter ever made. It's not because it has great features for working on tube gear. It's because the military used them in vast quantities, and you can get them for $20 a pop. I have 3 of them, just for spares, in case one of them goes south. I've got a backup. Now, that being said, they are very good meters, and they do what they do very well, and they're ruggedized and all that. But no, there are meters that have better features that are nicer to use that I could get, but I wouldn't get them for $20 a pop, and they wouldn't be available by the dozens on eBay. Same goes for the Tektronix 465 scope. Yeah, it's 40 plus years old. There are plenty of other scopes, newer scopes that have all kinds of cool features that I could use. But I got it for $43, and it just works. And there are dozens and dozens of them on eBay, and I think they're relatively easy to service and repair. There are tons of videos about using them, so that's why I got it. I try to get things that other people can get and are repairable or easily replaceable. And ideally have really cool features that are over the top for what I want to use, just because it makes things more fun and more interesting. So, with that being said, here are the 2 new items. The first of which very much falls into that category of exactly what I was just saying. I have never owned a benchtop multimeter. Certainly not one with any good capabilities or any significant build quality or high accuracy. However, the second item I'm going to show you, I expect will need to be repaired and or calibrated, and I'm going to need something like this to do it. In fact, there are videos of guys using this exact device to work on the other device. Now, there are loads of benchtop multimeters out there. This one in particular is another one that's 40 or years old. It was introduced in 1980, so that was 43 years ago. But there are lots of them on eBay. So I got this one because it was working, and it came with service manuals, and it's very clean. What is it? It is an HP 3478A multimeter. It's, I think, 5.5, 6.5 digits. Probably not use a single voltmeter with 5 digits after the decimal point. That's crazy. And it's jumping all over because I don't have the leads connected to anything. That's just picking up stuff out of the air. Even if I short the leads together, I think it's still going to register a little bit. I don't know if that's just literally picking up RF out of the air, or it needs to be zeroed out. It was $100 or thereabouts, plus a few bucks for shipping, and it just works. Now, part of the reason that this is so complicated is because it has the HPIB interface, Hewlett-Packard interface bus on the back. That thing. And that accounts for probably half of the electronics inside or more. This thing has 2 microprocessors inside of it. That bus allows you to program this. It wasn't, or one of the intended purposes was to put on a production line, automate testing. This thing can read, I think, up to 72 samples a second or something like that. And you could log it, feed it back to a computer. You hook this up to a network. You have a bunch of these. Or to do data logging, experimentation, laboratory kind of stuff. Fancy stuff. I don't need that. I will probably never use that. I don't have anything else to hook it up to. So no, I don't need it. I got it because there's a whole bunch of these on eBay for $100 or less. I could have taken my chance of one that had some issues. I could have got one for probably $30-40 if I shopped around. New, these were $1,000 or so, and I just looked at an inflation calculator. That's about $3,500 in today's money. I would never go out today and buy a new meter for over $3,000 unless I was running a business that calibrated test equipment or repair test equipment and guaranteed that it would be a certain level of accuracy. I'm a hobbyist, somewhat of a side business, of course. I don't need this to fix a vintage TV, of course not. Although I may need to use it to fix some test equipment. I got it because I could. I got it because they're readily available, and it's a neat thing to have that I could have never owned in 1980 when I was 10, 11 years old. These manuals are a trip, too. They're both about 100 pages long. Would you imagine a 100-page, 8.5 by 11 manual to use a multimeter? What can it do? It can measure volts, current, and resistance. Can't measure capacitance, inductance, frequency, none of that fancy stuff, no ESR, nothing like that. But what it does very, very well and very, very accurately. And to be fair, half of this manual is on how to program it with that interface bus, and there's Visual Basic programs in here and all kinds of craziness. I looked up, curious to see, to hook this up to a modern computer via USB, to get an actual official HP Agilent adapter USB to HPIB or GPIB, $400, $500. I saw some cheapo ones, generic ones for $50, but the feedback comments on Amazon were they don't work with Hewlett-Packard stuff. They don't conform to the standards. They won't work with Hewlett-Packard software. So if I ever did want to use this, getting the adapter to hook it up to a computer would cost more than the device costs. Probably never will. But the rest of it is about actually using it. I think it's kind of funny that it has a self-test. You turn the thing on, it goes through a power-up check. Self-test, okay. Now you may notice right away, hey, there's 4 sets of leads here. It's just use conventional banana jacks, nothing fancy. Well, it goes up to 300 volts, so it's not Cat 3 or Cat 2 certified or whatever. And I would never use this on a TV or a tube-based radio. It's a little too fragile for that. But the 4 inputs, that's for using, for doing resistance check tests. If you use a 4-wire system, which means you have 4 leads and 4 clips, it can compensate for the resistance of the actual wire. When you're talking about this level of accuracy, yeah, the resistance of your test leads matters. Or you can just use 2-wire mode. So I'll just quickly demonstrate here. Let's do 2-wire ohms. I have my leads shorted together, so it's basically telling me that the resistance of this wire is about 0.2 ohms. Let's just grab a random resistor here. This is supposed to be an 18K 5% resistor. Let's just hook her up here and see what we get. 17.8518 kilo ohms. So there you go. It works. Have not tested the voltage or current modes yet. I will when I have a need to. You can do a few other things. You can, so by default it's auto ranging. You can turn that off and set a manual range. You can control how many digits of accuracy it has. So right now we have 4. I can go down to say 3. Now it's just 17.85, or rather 2 digits. But it updates much, much, much faster. So if you were doing production line testing, or if you were, say, sampling a thermistor and you wanted to log the data as temperature's changing quickly, you might want to go with the lower mode. Less accuracy, faster reading. So, just some neat stuff like that. Alright, let's get to the fun thing. Let's get to the ginormous box that I could barely even lift into the house. It was so big and heavy. Oh, wait, hang on, not yet. Let's take a quick look at the service manual, which I think is also a trip. This is part of the reason I got it too, because having to buy this, I would imagine, would cost a bit of money. There's a lot in here. So it has all kinds of info about theory of operation, calibrated performance testing, replacement parts, and then the service with all the schematics, and there's a bunch of programming stuff too. So there's a basic program you can use to verify some operation, but I want to show you the schematics and the parts placement diagram. They really went above and beyond. Again, it's a multimeter. This is just the power supply. And something I think is cool to look at when it comes to test equipment, it's just if you can get the service info to check out how they built some things. Especially from higher end brands, because they didn't spare any expenses. So these are just conventional 3-terminal regulators, a 7805, 7815, but they put in a thermistor. They put in reverse voltage protection Zener diode. They put in an over voltage protection diode and on all the regulators. In other words, they did all the stuff that you would see in application notes if you want to get the best performance, get the most protection out of a design. And that goes on and on and on, where everything is, you might say overkill, but when you're paying that kind of thousands of dollars for a meter, that's the kind of stuff you would expect to see. And I don't doubt, if I look at the inputs, that they have all sorts of protection on them as well. And then, as I say, that there's a whole computer in this thing. That's towards the back here. Here we go. They don't label the processors. HP back then was kind of big into making their own computers and calculators and such, so they may very well be their own. I don't know. There's the A to D converter. It's a hybrid. The microprocessors, there's nothing on them. It just says it just has a part number. Not even a part number. I mean, just the part designator, U462. and U501. Even the ROM and RAM, they don't specify part numbers on them. And there's a transceiver for the HPIB bus. Again, it's a multimeter. It's also a computer. So, yes, I just got this last night. I barely had a chance to look into it. All right, now the big item. Oh, man. And as far as my address being visible, you guys warn me about that all the time. I don't care. I routinely have people dropping stuff off, picking stuff up. It's no big secret. Oh, man, this thing is well sealed. Now, another topic that's been brought to my attention, which I was well aware of, is, yeah, if I talk about something, that will increase demand. But you know what? Most of the stuff that I show, I found out from somebody else talking about it. I think Fran Lab did a video about a while about micro-influencers. I mean, I don't have that many viewers. I don't think I'm a trendsetter exactly. But yeah, I mean, same with the forums. It's always been this way. It's been this way since the dawn of collectibles. If people are interested in something, the demand goes up. As there's a limited supply, the price goes up. That's the way it is. All right, so what is this? Well, so I've been talking about sleep generators, and I mentioned briefly in one video that there was a great Hewlett-Packard one that could kind of do everything. I'd mentioned that was sort of a unicorn, a sleep generator that would do everything, be everything. This actually can. It's massive overkill for doing TV or radio alignment. Generally speaking, it's a laboratory-grade device. And they have a number of models, including current production models that can do all kinds of great stuff. But this is the one in particular that I was thinking of. And now, how did I know about it? Because I was talking about alignments a decade ago, and somebody else mentioned to me, hey, if you ever see this one and you can get a good deal on it, you should pick one up. I did, and I did. Maybe. Here's the thing. I intentionally bought one that wasn't working. Why? Because these are expensive. If they're fully functioning and in good condition and all that, even though they're, I don't know, 40 years old, they're can go for a few grand. It's an HP 8662A synthesized signal generator. Some say the finest signal generator ever made. Certainly at the time it came out, it was. There's many years, or several hundred, I think, engineer years or put into this. What am I trying to say? A lot of very clever people spent a lot of time and effort creating this. It has some of the lowest THD phase distortion of any device, and ridiculous accuracy. It can go from 10 kilohertz to 1.28 megahertz. It's something like 0.1 hertz resolution. But, I mean, I already have a good RF generator that has similar range, the 657. This is also a sleep generator. And it can do AM, FM, and PM. And you can program, I believe, up to 4 markers. But again, doesn't turn on, doesn't work. My thought process is that I have a better chance of fixing one that's just dead versus one that turns on but has obscure, complicated errors. In other words, maybe it's just the power supply. And in fact, there are some really good videos, one in particular. I don't know if it was produced, well, it seemed to be produced by somebody who's very professional. I don't know if they were associated with Hewlett-Packard or they work on repairing Hewlett-Packard stuff, but they have a multi-part series on troubleshooting and repairing the power supply in one of these devices, and that's what a big part of what encouraged me to try it. And wait till you see the insides of this if you've never seen it before. And it's got a knob. You know, I kept complaining about the other ones not having a knob. This has a knob. And a bunch of buttons on this cool kick-out panel. Bunch of displays. They're dot matrix LED displays. So, I clear some space, muscle this up onto the workbench. It weighs 85 pounds, 70 pounds, something like that, plus there's a lot of extra because of all the padding in the box. And let's pop this open. After you take the feet off, there is one screw in the center of the top panel. You take that off, the whole top panel comes loose. Prepare to be amazed. How is that for some insane modular RF engineering? Oh, what a trip. So each one of these are all pull handles. These modules are on a back plane, 2 back planes running through it, all with these RF interconnects, so you can disconnect these and pop the modules out. Also, quite a few of the modules have status indicators, red LEDs that light up if there's an error, and holes for doing your calibration and tweaking. Curious Mark, if any of you watch him, he works on stuff like this, and Apollo gear and all kinds of high-end vintagey stuff. He got one of these. It's an old video, 10 years ago or so. They're short, not the greatest quality. But he goes through and he uses that same HP multimeter I just showed you, and he goes through and he has to adjust some of these, and he goes through some of the service checks. That also gave me a good idea of what I was in for. And a curious thing, between the power supply repair video and Curious Mark's PLL rather, troubleshooting videos, these boards individually are not that bad. And there are 2 capacitors in particular in the power supply that seem to be underrated. I'm not joking, there is an insane amount of electronics packed into this. So I just took out one cover thinking one module would come out. No, it just exposes a bunch of circuit boards. Everything's color coded and amazing looking. Now we can date it. So I'm seeing 85, 48th week, 1985, or 1988 rather, 85, 85-18, 85-48. So I think it's fair to say this was made in late 85, early 86. It's TTL logic, 74LS 273 is a whole bunch of them, 74 184. A few proprietary or national parts. It could be gals or pals or who knows. This is what I mean by, hey, okay, nothing socketed, but we have 2 tantalums on here. If one of them was shorted, it's not entirely implausible that this could be repaired. Here's a little flyby over the modules. Everything is labeled extremely well, color-coded, part number, function, designator. And here's the power supply. I started taking the screws out. Clearly, it's been worked on before, and they did a really clumsy job with these screws. They gouged them up pretty good. Don't think these have been taken out though. What I really want to do is get at the same card that I saw in that repair series and see if the same 2 caps are bad on this, or at least, not especially because I've seen it's been worked on. What condition, what's going on inside of this box here. Well, this is interesting. Here's one of the boards. Visually, looks fine. Hasn't been worked on. Here's another module. It's a sandwich, so you can't easily see inside, but no obvious visual issues. Hasn't been worked on. Then we get to this board, which is the main heart of the power supply. It's rather heavy with these transformers and inductors and heat sinks and dust bunnies, but hey, look at that. These are the 2 caps that are the troublemakers that I saw in that other video. Have they been replaced, or are they originals that have gone bad? I can't tell. But clearly something bad has been going on in this area. There's some serious charring here. So it's a switch mode power supply, and there are two hefty rails, plus or minus 160 volts, and a lot of current, so to speak, is going through these caps. And when the other service tech replaced them, I think they were 250 volt, 22 microfarad. I think he used like 450 volt, 22 microfarad. I wish I could see a date code or something. But it's entirely possible. I compared this board to that excellent repair series on YouTube, and these caps match the originals in his video. So these are the original caps, and these are the ones that are prone to go bad. So I took them out. I pulled out an ESR meter. I have a couple. I think is the better of the two, and let's give this a try. The only downside is this is meant for axial, not radial, so a little awkward to check, but let's see what we get. 12. That is pretty high. Less than 2 would be nice. Let's check out the other one. 6. Now let's compare it to some new ones. These are 450s. 2.5. And these haven't been used in a while, so they're not formed up as well as they could be. So I'm going to try tacking in a couple of these and see if it does the trick. Oh, let's try my other ESR tester too, if I can find it. This is just one of those little cheapo testers that are all over eBay. Let's see what we get for capacitance and ESR with this guy. ESR, 11 ohms, 22 microfarad. Let's check out the other cap. .22 microfarad, about 5 ohm. So not horrible, but from what I read or saw in that video, this is a critical part of the circuit. And here we go, not exactly perfect, but I think it's good enough to see if that fixes the problem. So, here we go. A little tough fitting these in. I think I'll definitely want to get some smaller caps. There we go. Alright. Unfortunately, that made absolutely no difference. It still just powers up for half a second and shuts right back down. So I buttoned things back up. I think I'll call it a night, and I'll get back to studying the service manual and tutorials and see where to go from here. Well, I put this aside, went back to working on a predictor, and then I did a little research online. I found the service manual, all like 1,000 pages of it, and I started watching the video series again about checking out the power supply. And he went through these boards, and he methodically checked all the caps and all the diodes on all these boards. So I opened it back up, and I pulled out the boards, and I got my ESR tester back out, and started going through the caps, and I got to this guy. And it didn't register as anything. Lifted up one leg. Tried both. Yes, the ESR tester and this guy. And it just showed open, just non-existent. So I tacked in a replacement, and let's see if that actually did anything. Here we go. Are you kidding me? This was causing all that trouble. Okay, well, now that we have it, we can check some status lights. Well, we have green lights on this. I forget what those are, so I'll put the panel back on. Let's see. I thought this thing would be rather loud, and yes it is. Okay, so I guess those lights mean that we have all these supply rails running. But this is not so much fun. We have an error. 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 Well, let's turn it around so you can actually see what the displays up front show. Okay, sorry this thing is so darn loud. I'm having trouble getting it to do what I think it should be doing. But after pushing a whole bunch of buttons and playing around with it, I finally got to put out something. When I just flat out told it to give me like a 10 megahertz signal, I was getting nothing out. And I started playing around with sweep modes and finally started doing something. It's doing a huge range, and that was what was already programmed into it. So it's pretty wild what these displays says are starting or stop frequency. I threw on some AM modulation just as I could, and that very large output level. I can't get this wheel to do anything, but the these were doing something earlier. Let's see, gotta change the amplitude. Yeah, I didn't really seem to change the amplitude much on the scope. How do you minus? Yeah, so as I'm playing around with this amplitude on the scope, is it really changing? Might not have it terminated properly, though, so it might not quite understand. But now, of course, I have a bunch of error code, so I shouldn't really expect this to work properly. And if I turn the sweep off, it seems like it should just be outputting. Oh, is that just 5 hertz? I thought it was 5 megahertz, but the megahertz indicator isn't turned on. Frequency 6 megahertz. What if the lights burned out? So there's gigahertz, megahertz, kilohertz, and hertz indicators here. 1, 2, 3, 4, 5, 6. Oh. Well, alright, kilohertz button worked. Let me put a little bit smaller number in there. Sorry for the horrible camera work, but I'm kind of jazzed right now. 5, 6, 7. I found a nice little abbreviated troubleshooting error code guide to this device, and it says error code number 1 means there's no reference oscillator. And I read the operator's manual, which is massive, and eventually found a section on reference oscillator, and it says that there are controls on the back for it. So yeah, we got a bunch of inputs on there for power, HPAB, external markers, modulation, cooling fan, Okay, yeah, it said there were buttons. I didn't see any buttons on the back before, but yeah. Buttons. Sorry, the camera's upside down, but internal, external, external. Well, let's see. Yeah, these are push buttons. Let's try internal and see what that gets us on. There's an explanation over here. 10 megahertz, that's pretty standard. There's probably a crystal oven inside for stability. So that would be the master clock that's driving this whole thing. So yeah, without that, I could see why we would have a lot of problems. Let's give it a whirl. Okay, let's see if error codes. Oh, a lot less error lights. Do we have any error lights? We still have one. Just one, though. On the AGC A4A7 unit, error 10B. And yeah, error lights still flashing up front. And error 10. Well, that'll be the next thing to look up what that means. But let's see if it's doing anything. So I have it hooked up to my scope. Oh yeah. Wow, yes we do have something. We have a very clipped sine wave. Well, let's try changing the frequency on it. So we're at 150 kilohertz. Let's try 200. Yes, frequency doubled. Let's try 50. Yeah. Frequency 5 megahertz. I'm thinking the light's burned out. There should be a light indicator behind each of these. But anyways, yeah. It looks like it could be 5 megahertz there on the scope. Increase our time base. Yeah, so that's a very large amplitude, and it's clipped. Can we change amplitude? Yeah. Maybe. Amplitude 10. Amplitude 20. Yeah, okay. Okay. Something like that. A little more playing around to figure out how to set the start and stop frequency for the sleep generator. So right now I have it going from 10 to 50 kilohertz with big steps, very slowly. So that's another reason I wanted to get this and get it somewhere working, is I think it'd be a really good aid for demonstrating how sleep generators work, because you have this kind of flexibility. So let's see, I can sweep it a lot faster. It's pretty trippy to look at too. Alright, I gotta stop. Hope you enjoyed this look as much as I did at some new Hewlett-Packard test equipment. Expect to see a lot more of this in the future.